Well, in the previous topic, we have seen a basic idea behind the relational database. What is table? What are rows? What are columns? Constraints, primary key, foreign key. Now, if you want to design some database, what things need to be taken care? If your data needs to be maintained correctly, how it should be modeled, how many tables should be there, who is in relationship with whom, and all that things needs to be decided in a well organized manner. That process is called as data modeling. In which table you are going to store what data, how that table is associated with multiple other tables, those things we will see in this session. So when you talk about the data modeling, first you will imagine a term called as entity. Now client has given you requirement. I want to store the employee information. So client has given the requirement like this. Need to store employee information. Now see, in this sentence, the employee thing would be considered as entity. When you say entity refers to one table in the database. Entity refers to table in the database. So when you talk about entity, from this requirement, you need to extract how many entities are there. Presently, would be having one table, that is one entity. Need to store employee information. One employee belongs to one department. And see, I will add few more things. One employee belongs to one department. Next thing, one employee belongs to one department. Now see, this statement says that there is a employee entity, as we have said this, and there is one more entity we have identified, department. So this process is called as entity identification. How many entities are there? Then inside entity identification, what attributes are there? What attributes? Attributes means columns. So need to store the employee information of employee birth date, employee salary, employee department. See, need to store the information of employee for employee birth date, employee salary, employee department, employee city. These are the attributes. Remember that. These are what? Attributes. And these attributes would be having different types, such as strings, number, dates, depending on what data they represent. Age, right, is a number. DOB is a date, like that thing. So you need to define the attribute. The attributes we have seen are the columns. The next thing, relationship definitions. So here if you see, one employee belongs to the one table, which means that for every employee in this table would be having few rows in this table. So one row of this table represents one row inside this table, department table. One row of this table will represent one row of this table, relationship. Again, I am saying one row of this table will represent one or more rows of this table, relationship. So you need to define the relationship. Relationship can be one to one. One row of this table can define only one row of another table. One row of this table define multiple rows of this table, one to many or many to many. We'll see. We are going to see this in details. That's the relationship definition. Now there is something called as entity relationship diagram, which is a next chapter actually. Here we define whatever you have done over here: entity identification, attribute definition, relationship definition. We draw it visually. We articulate this in the terms of image. We draw the picture of this thing, because these things, if you write in the text form, might not be well understood by non-technical people. But if you draw it pictorially, that would be well understood by everyone. And that is nothing but what the ER diagrams. ER modeling is a popular technique used to represent the entities in a domain and their relationships, right? ER diagrams help to visualize the entities. Remember that. Entity and its relationship are presented in one diagram. We are going to see that in detail. Normalization and the denormalization. Now, remember that in a one table, in a one big table, you cannot store employee information and department information and the tax information. One big table you will create. So columns would be employee information as well as the department information as well as the tax information in one table. A very, very bad idea. Why that is a bad idea? We are going to see separately. We have a separate session on the normalization. So you need to divide the tables. So this much data, we can say this much data would be getting stored in one table. This much data would be getting stored in one table. Department data would be getting stored in another table. And tax data would be getting divided or stored in another table. And all these tables would be related to each other. But you will not create one big fat table inside your database. And you do creating the tables at that level, further decomposition. So one table, one big fat table can be decomposed in the little tables. And this can be done till that situation where no further decomposition is possible is called as normalization. Is called as what? Normalization. So normalization helps improve the data integrity, minimize the data duplication, and ensure the efficient storage and the retrieval. Dividing the tables in such a way that no further division is possible. Not all the time normalization helps you. Sometimes you need to denormalize the data also for high performance, generally at the time of reading the queries. So normalization, dividing; denormalization, combining. Then indexing. Whenever you are searching the data, you index is a particular data structure which allows you faster searching and the sorting. You say that generally employees are getting searched by employee name and the employee ID. So you'll create the index. Index is a special data structure which allows you to faster search and sort. Don't worry, we are going to see this practically. We have a practical on this. Now, too much of the indexing is very bad. Now, data modeling. See, data modeling is an iterative process. Involves collaboration between the stakeholders, business analysts, and the database designers. It requires deep understanding of the domain, business requirements, and the relationship between the entities. Remember that effective data modeling results in well-structured, normalized, optimized database design that facilitates the efficient data management and the retrieval in the relational databases. Remember that this is an iterative process. You cannot do it in one go. So whenever you talk about the data modeling, remember that you are talking about creating the optimized database structure. And for that, you can keep these things in your mind. Right? This is all about the data modeling. We are going to do it practically. Don't worry. Yeah. Thank you.